Hello, welcome again to Aspiration International School, and this is another of our chemistry lesson. And I know you guys are facing a lot of difficulty with the limiting and excess reactant, and I've assigned this some time back. So I hope that you would have really tried this question before you watch this video. That way, you will really benefit. Now, remember, this is a topic of limiting and excess reactants, right? When you react two chemicals together, two reactants together, very rarely they will both completely be used up, all right? You will have one of the reactants being the excess left over together with the products. So we have this question here, all right? 3 moles of ammonium nitrate reacting with 1 mole of sodium phosphate to produce 1 mole of ammonium phosphate and 3 moles of sodium nitrate. So we are given 30 grams and 50 grams of each reactant respectively, and we are to find out based on mole calculation which is the limiting and which is the excess reactant. Now we're going to get started, right? Now remember, if you have any questions, do ask in the comment section, all right? I'll be watching and I'll answer every question that comes on. All right. So we are given 3 moles of ammonium nitrate. All right. And we are given 1 mole of sodium phosphate. So it's 3:1. Okay. So we are given here 30 grams, and we need to find our moles. Mole is represented by the letter N. Okay, so the number of moles is mass over molar mass, so it's 14 plus 4, okay, plus 14 plus 16 times 3. All right, what does that give us? So it's 30 over 80, so the number of moles is 30 divided by 80, so it is, so we have 0.375 moles supplied by the question, right? Now the mass that is given, sodium phosphate's mass that is given is 50 grams, all right? And the number of moles is 50 divided by 23 times 3 plus 31 plus 16 times 4. So you've got 50, all right, divided by 23 times 3 plus 31 plus 16 times 4. So you've got 164. So you've got 50 divided by 164. So you've got 0.305 moles being supplied. 0.305 moles of sodium phosphate. Let's double check. All right, that's correct. Now comes the question that I usually ask students, all right? Now, if you want to completely use up 0.375 moles of ammonium nitrate that is being supplied, how many moles of sodium phosphate do you need? Well, you take 0.375 divided by 3, you will need 0.125 moles of sodium phosphate. Now, uh, then I will usually ask my students this question: do you have enough? Do you have 0.125? Right? Do you have 0.125? And the answer is yes. You have more than 0.125. You've got 0.305. So immediately you know who is the one in excess. And how much excess moles of sodium phosphate do you have? You need to do a subtraction. You've got 0.18 moles in excess. So sodium phosphate is the one in excess. Now, in order to reinforce the learning, I'm going to ask my students, right? If you want to completely use up 0.305 moles of sodium phosphate, how many moles of ammonium nitrate do you need? Right? So then the answer is you got to multiply by 3. So you need 0.915 moles. So do you have enough? Do you have what it takes? The answer is no, you don't. All right. So these are not the actual values, and these are the values that actually um, reacted. So I hope that that is clear. Now we can answer the question already. All right. So we know that for A. All right. So the answer is the limiting reagent is ammonium nitrate. Okay. B. Now, before we proceed to B, remember that I usually advise students to write down the moles of each species. So we are going to do that now. All right. We are going to do that now. So let me rewrite the equation. So you have 3 NH4 NO3 and A3PO4. You have ammonium phosphate and 3 sodium nitrate. All right. So remember that this is the number of moles that reacted. So you've got um, 0.375 moles of ammonium nitrate reacting with 0.125 moles. We already established that earlier on. So how many moles of ammonium phosphate is being produced? 0.125. And how many moles of sodium nitrate is being produced? Well, it's 0.375. We get them from the moles. Yeah. So that is clear. Now look at B. What is the maximum amount of each product that can be formed? Well, usually they want the answer in grams, right? The maximum amount, usually they want the answer in grams. So we're going to attempt part B together here. So product. So the first product is ammonium phosphate. Okay, and the number of moles would be 0.125. Now how do we get the mass? How do we get the mass? Answer in the comment section. How do we get the mass? Right, so we multiply the moles with the molar mass. So we take 0.125 multiply with 14 times 3, okay, plus we got 12 hydrogen atoms there, right? Um, phosphorus and 4 oxygens. So what is the mass of 1 mole of ammonium phosphate? It's 149. We multiply that with the moles. We've got 18.625 grams of ammonium phosphate. Well, I'm halfway done. So now the next product would be sodium nitrate. Okay, and the number of moles would be 0.375. So again, to calculate the mass, you need the mass of 1 mole, or we call it the molar mass of sodium nitrate. So we've got 23 plus 14 plus 3 times 16. 85. So we have 31.875 grams. And that is how you answer part B. Now let's look at part C now. How much of the other reagent is left over after the reaction is complete? And I want to bring your attention to this part here. Remember, there's remaining 0.18 moles of sodium phosphate that is left over, not being used. And for part C, they are asking us for the mass. So the moles is 0.18, and to get the mass of sodium phosphate, the excess reactant, right? We take 0.18 times 164. We already got the molar mass earlier on. That will give you 29.52 grams. And that is how we solve this question. Now, do you have any questions? Please ask in the comment section now. I'll wait. Okay, the rest of you without any questions. Okay, if there are questions, I'll answer them now. For those of you who are done, please get ready question number 2. All right. I hope what we did in question number 1 will help you to answer question number 2. Question number 2 is essentially the same thing. It's just a different type of reactants. And I'll be there in a moment. So you all can try that out first. Any more questions? Keep them coming in. I'll be answering them. Okay, let's move on to question 2. So this is question 2. So it's essentially the same thing. I feel more comfortable writing out the equation even though it's already there, yeah? So we have here, all right, so we have here 3 moles of calcium carbonate reacting with 2 moles of iron phosphate, iron 2, iron 3, and 1 mole of calcium phosphate being formed, and 1 mole of iron carbonate. All right, so that's the question. So then again, let's find the moles and let's compare the moles of both reactants. Okay, so these are the 2 reactants, calcium carbonate and iron 3 phosphate, and the mole ratio is 3 to 2. Okay, so we are given, all right, so we are given 100 grams of calcium carbonate. So we are given 100 grams of calcium. Remember, if any questions, keep them coming in. Keep them coming in, all right? I'll answer them. I'll go slowly. All right, so the number of moles is 100 grams over. Now, do you remember the molar mass of calcium carbonate? I told you this is one that you have to memorize. Do you remember? And if you did memorize, it will do you good because you know that the molar mass is 100, so the number of moles is 1. Let's find out how many moles is being supplied by 45 grams of iron 3 phosphate. So we've got 45 grams here. Alright, so the moles will be 45 over, okay, iron 56 plus 31 plus 4 times 16. 145 over 151. All right. So you've got 0.298 moles being provided. So now, let me ask you this question. All right. So the ratio is 3 to 2. Now, how many moles of iron phosphate do I need? Given this ratio, how many moles of iron phosphate do I need to completely react with 1 mole of calcium carbonate? Put down your answer in the comments now. You need 0.667 moles. So my next question is, do you have 0.667 moles? You don't, right? You just absolutely don't. All right. So this would be the values that did not react. Automatically you know because you don't have. You only have 0.298 now. Come. My next question is, if you want to react all of iron phosphate, okay? How many moles of calcium carbonate would you need? You need 0.447 moles. Now, do you have enough? Yes, you do. You have 1 mole and all you need is 0.447. So how many moles is in excess? So automatically you know that since you have more than what is needed, this is the calcium carbonate is in excess. But how much more in excess? Well, you've got 0.553 moles in excess. So let's go back to the equation here. So how many moles of calcium carbonate reacted? How many moles of calcium carbonate reacted? Well, it's 0.553. And how many, we got that from here. And how many moles of iron phosphate do we have? Yeah, it's 0.298. And how did we get that? Well, it's right here. Okay. So, all right. So now, how many moles of calcium phosphate is there? Put your answer now. How many moles of calcium phosphate and how many moles of iron tricarbonate is being produced? Put your answer down. Yeah. Well, you can very easily take 0.298 divided by 2 because this is 2:1, right? So 0.149. And how many moles of iron tricarbonate is being produced? Put your answer down. It's the same thing, right? Very good. Thank you for those who are trying. Okay. Now, let's answer the question A. Which of the reagent is the limiting reagent? I think since we know that calcium carbonate is the one in excess, therefore this will be the limiting reagent, right? So immediately we know the answer is iron phosphate. Because when one is the excess reactant, in this case it's the calcium carbonate, automatically the limiting reagent will be the iron phosphate. Now I hope this is clear. Is anyone still not clear about this? Because if we are saying that calcium carbonate is in excess, that means iron phosphate has already completely reacted, and that is what they mean by limiting reagent. Okay? So now, what is the maximum amount of each product? Let's look at calcium phosphate. Right. Let's calculate the mass. All right. Let's calculate the mass. All right. So the mass would be the mole 0.149 multiplied by the molar mass. So calcium is 40 and there's 3 calciums. phosphorus 31 times 2, and in total we have 8 oxygens. That's right. 0. Yeah, sorry, 149 multiply with, come on, all of you, put down your molar mass in the comment section. If you haven't subscribed to our channel, can you please subscribe now, please? All right, so then you can get updated with any new videos that we post up. All right, 310. Did anyone put 310? Very good, 310. So the mass will be 46.19 grams. Let's work out our next product, which is iron 3 carbonate. So the mass will be 0.149 multiplied with, let's find out. Iron is 56 and there's 2 of them. Alright, carbon is 12 and there's 3 of them. And oxygen is 16 and there's 9 of them. If you have any questions, just put them in the comments section. Let me have a look at the comments section. Alright, so put down the molar mass. What did you get? 292. I got 292. Did you get 292? $43.5 grams. So I've answered A and I've answered B, and now we are going on to C. Alright. So for question C, it's asked us how much of the other reagent is left over, the excess reactant. How much is left over? Let's answer that now. So if you remember, we have 0.553 moles of calcium carbonate that's not being reacted, and we need to find the mass of unreacted, all right, calcium carbonate. So we take the moles times the MR, okay, and the moles is 0. If you already have the answer, can you put the answer in the comment section right now? So the MR of calcium carbonate is 100. So out of 100 grams that's being supplied initially in the question, we have 55.3 grams left over. All right. So that is how we solve these two questions. So I hope this video has helped you, and if you're unsure, please drop your questions right now in the comments section and we will deal with it. I will answer your questions. If there's any questions, please reach out to me, to your friends, and we will definitely help you. Okay, now we're going to end the video. All right, and I'll be answering the questions in your comments. So thank you for watching, and we hope this video has helped you. Okay, goodbye.